G'day everyone, welcome to my glider design project experience. Before we begin, let's go over the requirements. They were simple. The glider we made had to be primarily made out of balsa wood. It must fit within a 16-inch by 16-inch space and be able to fly at least 20 feet. I decided to construct my glider at home because I had plenty of wood I could use there. Before designing my glider, I did some test flights with the model kit for reference, and it actually almost got 20 feet consistently, so I figured that making a glider wouldn't be too hard. So I started designing, and that's where I ran into my first problem. The balance I was using, it's terrible! Like, it literally has a maximum sig fig of 1. Not even. Anyway, so I went on designing with minimal math and calculations, and this is the glider that I made at first. Boom! Materials was easy, balsa wood. I had easy access to it, and it was light and strong, so I saw no other alternatives. The wings have these dimensions. I kept it somewhat regular with a small taper, rather than the more efficient elliptical shape because it was easier to make. I also tried to make its aspect ratio higher by keeping it somewhat skinny, and I placed the wing a bit closer to the back because I figured that would place the wing a bit closer to the center of gravity, meaning I wouldn't have to add a nose weight later on. I considered using a dihedral to add more stability to my glider, but once again, I decided against it due to construction difficulties. The tail had these dimensions, and the fuselage itself was 12 inches long. As for sizing, well, because I actually didn't have a reliable balance, I kind of just eyeballed everything. So I tested it, and utter failure. Complete reset. I redesigned the glider, but this time with my own added requirement. I didn't want my glider to look like everyone else's, because I figured most gliders would have this general design, so I looked to Google, and that's it. That's my new design. Put the horizontal stabilizer on top of the vertical stabilizer. Every other dimension stayed pretty much the same, as in I simply reused the wing, the tail, and the fuselage. And I did add 2 vertical stabilizers because one was not enough to hold the other tail. I also did move the wing up the fuselage because it was difficult to throw when it was close to the back. Now, I knew this design was going to need a nose weight for stability, so I tested with Play-Doh, changing its placement and mass until it balanced. Oh, wait. After some more testing, I did some more iterations. I moved the wing further back to reduce the mass I had to add up front while still giving my hand room to throw. At this point, my glider was stable on a good throw, just it didn't go very far. So I reduced the size of my tail to these dimensions to reduce drag. This flew farther, but there was a problem. It kept banking to the right every flight. The problem? A construction error. Yes. The tail isn't flat. At this point, I didn't want to change my tail anymore, so I added some winglets, hoping that they would provide some horizontal stability. I also did a lot of sanding to make my fuselage more streamlined, and I figured I could make my wing even skinnier to increase its aspect ratio, so now these are its new dimensions. I should also mention that the balsa wood has a thickness of 1/16 of an inch. That might be important. At this point, I was done Play-Doh testing, so I looked for a more solid nose weight. And I found some coins and figured that Jefferson was going to provide the most stability to my glider. And this was the last of my testing. I got a best flight of 34 feet, and I was satisfied with this, even though it still ranked a little bit. For the rest of the week, I did nothing regarding this project, but the Wednesday before launch day, I did go to the Burger Bowl to do some more testing. And by testing, I meant throwing practice, because oh boy was I bad at throwing. Also, my winglets broke, and I decided not to glue them back on because they didn't seem to be doing much. And then it was launch day. My first launch got 30 feet, which is pretty good. It met the requirement. I did not win the tournament, by the way, but I got to try again, and after a few more launches, I got a best flight of 50 feet, which is also pretty good. Here it is. I don't forget, but the wind is blowing.
That's fine.
So, here it is. my final glider inside a 16-inch by 16-inch box. Calculating the center of gravity was rather difficult because I actually didn't calculate it. I used crude methods to find the center of gravity of this glider. This is actually what I did during the iteration process to determine where to place Jefferson in order for my glider to be stable. I found my center of gravity to be under the wing, yet still behind the quarter chord, meaning that I should have had a slightly heavier nose weight. Sorry, Jefferson. As for the coefficients of lift and drag, I used this formula which relates the coefficient of lift to the angle of attack, assuming that the wing airfoil was flat and it was small enough, which I think it is. Using the video of my best flight, I found that my glider has a coefficient of lift of 0.722 when it flies at an angle of attack of 6.5 degrees. And for the coefficient of drag, I used this formula. Yes, I did have to estimate a few values, but using the coefficient of lift that I found earlier, I calculated the coefficient of drag of my glider to be roughly 0.167. Of course, these are all just estimates, as I don't actually have the resources right now to experimentally find the exact value of my lift and drag coefficients. There were a lot of things I could have changed throughout the course of this project. The construction error at the tail, which led to my glider consistently banking every flight, could have been done better. Had I had a better balance, I could have actually done calculations, and that could have led to a better glider. And I did also later find out that the balsa wood I used was for some reason a bit denser than everyone else's balsa wood, even though it was just balsa wood, so that made my glider a bit heavier than everyone else's. But in the end, it didn't really matter. The requirements weren't that hard, it was just 20 feet, so I had fun. That's all that mattered, and I learned a lot, so that's all for today. Thank you.